Welcome everyone to Database Misconceptions, understanding the differences between NewSQL and distributed SQL. I built this webinar for just about anybody out there, whether you're a business owner or technical leader. My goal here is to help answer that question we hear pretty often from customers of, isn't NewSQL and distributed SQL, aren't those the same thing? Well, I'm here to put my official viewpoint out there and clarify that question exactly. Now, as a quick way of introduction, my name is Michael Haig. I'm the head of product marketing here at Yugabyte. Prior to Yugabyte, I spent 6 years leading product teams at VMware, and before that, deeper in the stack, focusing on storage and networking technologies. Now for today, I've entitled this session Common Misconceptions. Now we all have common misconceptions, and I'll get to NewSQL and distributed SQL in a second, but let's have a little fun with this first. Now, we all have heard these wives' tales, don't swim after eating, coffee stunts your growth, or my son's favorite, the 5-second rule. Now, we know all these aren't true. If you get a sticky gummy bear anywhere close to the ground, much less to drop it, it's going to pick up something weird and your kid's going to eat it. But what about some other misconceptions that maybe we have that maybe we aren't sure are true? So I pulled up one of my favorites that I did some research on. We've all heard this misconception, this idea that the Great Wall of China, it's the only man-made object visible from space. So if you go looking at NASA, sad reality is this is not true. As cool as the story it is, because the Great Wall, it's 13,000 miles, 21,000 kilometers. But the reality is it's built in a rocky, hilly terrain, and it's rocks that blend in with everything else around it. But there are some man-made objects that are visible from space. If you talk to astronauts that have been in low Earth orbit or spent time on the International Space Station, looking down on Earth, they can see, of course, cities, large highways, dams, and the one natural wonder they can see is actually the pyramid. Given the shape and the shadows it throws down, you can see it from space. Now, kind of why did I bring up this kind of random bit of trivia besides trying to keep it a little bit interesting to start here is this idea of perception. Again, if you look at the Earth today, 200 years ago, from space, it's going to be blue, white with clouds, green and brown for the most part. It's going to look pretty unchanged. If you think about the database technologies, at the high level, they're all fundamentally doing the same thing. They're storing data, they're keeping track, feeding that into our application. But as you get a little bit closer, as your perception changes, looking at it, you start to realize there's a lot of subtle differences. There's a lot of things that have changed in our IT world, just like in the world over the past 200 years, over the past 10 years, 5 years, in our IT landscape, and how we respond to that is important. So understanding those nuances is key, and that's really what we want to dig into today. Now, I like to start all my presentations by just getting straight to the punchline. So if I lose your attention as we go, at least you have these 3 takeaways to lead with. And I frame this conversation really around 3 misconceptions I want to talk about. So first and foremost is this idea that your digital transformation journey is really all about apps and cloud. Once you've mastered that, you're good to go. But the reality is, when you look at that, cloud, applications, and the data layer really form these 3 key components. So as you think about digital transformation, you've really got to think about all 3, and we'll peel back really the importance to that as we go. The second misconception, the heart of the presentation, is distributed SQL and NewSQL. Are those the same things? And the answer we'll get to and we'll walk through is fundamentally distributed SQL is this next generation. It's a new architecture that fundamentally has changed the game for databases, and we really want to understand those nuances so you can match those needs with your application and business needs as you go. And then third is this misconception that your existing data stack is good enough for the applications that you're running. And the reality here is that might be true. There's some nuances here, but what we want to focus on, and what I want to talk about, is the fact that we are seeing more and more use cases, modern use cases, and we'll talk about 5 specifically today, that are really driving the need for distributed SQL that no longer are well situated for the legacy monolithic databases that a lot of folks are still using today. So essentially, as you think about these kind of 3 columns, these 3 points, we're going to talk about kind of the when we should modernize, what we're modernizing with, and the why. So when, what, and why are really the crux of what we'll get through today. So let's start with that first one. Do a little bit of a look at the bigger picture before zooming in. And it's the question of, do we do database modernization now? When is the right time? And the misconception we hear all the time is, we know we all have tons of priorities. There's more and more being put on our plate that we have to address. So is now the right time to finally think about upgrading, changing the database that we're using? And to do this, let's again look back at that larger IT stack and what has evolved over the past 10, 20 years. If you think about the IT stack, I break it down. We have 3 core components there in the middle. At the top, we'll start with the application layer. It's a software world. We're all focusing on driving services, new solutions, expanding our business, and doing that through software. And then, of course, at the bottom, we have the infrastructure layer. This is our cloud, our networking, our storage, those core components, the big hardware that we can drop on our foot. And then in between, we have this critical data layer. This is the piece that's storing the data that feeds the applications, and it's consuming all that infrastructure below. I'm going to focus on that middle 3 stack today, but I do want to, again, acknowledge that wrapped around all of this, we have networking, we have security, monitoring, management, all these tools that are essential to bringing all these pieces together. But let's talk about this stack in the middle, because this is where, if you think about where we've gone, you'll start to realize it's critical that we kind of think through and truly look at the full picture here. So starting at the bottom and looking at the infrastructure, there's no doubt that how we view infrastructure today is radically different than 10 years ago, and definitely 20 years ago, and even 5. The emergence of public cloud, as you can see in the graph here, just plotting the growth from $10 billion, $15 billion back in 2010 to $150 billion plus market, and growing rapidly today. The investments we're seeing in growth in AWS, Microsoft Azure, and basically the re-emergence of Microsoft thanks to Azure, Google, Alibaba, Tencent Cloud. All of these things are kind of proof that, again, we've changed how we've done infrastructure. We've shifted from classic monolithic systems to commodity hardware. We've used virtualization to drive new efficiencies, and now we're leaning heavily into a cloud-first, public cloud IaaS model to help simplify operations, reduce those burden from all of the companies out there. So massive change in infrastructure. If we jump to that top of the stack, this one's a little bit more recent, but there's no denying the fact that our application world has drastically changed in just the past 5 years or so. Kubernetes, microservices, new app frameworks are fundamentally changing how we develop applications, how we think about applications, and how we run our business. Again, another just proof point on this is the data out there that shows just the amount of money going to app modernization services. $10 billion in 2020. In a couple years, that'll triple to $30 billion plus. And again, I'm sure everyone out there has been impacted by this. The DevOps buzzword, all the things around developers are putting a focus here. So a ton of change at the bottom layer, a ton of change at the top. But what about this middle data layer? If we look at where this space is, it's remained fairly static over the past 10, 20 years. If you look at DB engines, a great proxy for kind of all the databases out there and how they rank, those top 10 databases today, pretty much the same databases that were there 10 years ago. Number 1 on the list, Oracle. Oracle released their first relational database management system before I was born. And don't let the camera filters fool you. I'm not that young. I'm getting gray hair. It's been around for a while. Number 2 on the list, MySQL, has been around since 1995. The same year we saw Toy Story, the original Toy Story, not 2, 3 Buzz Lightyear release. So it's been out there for a long time. Now, these are amazing technologies that are doing a lot. But I think the key thing to note here is these are technologies that were created, architected, before these notions of app modernization and cloud were even kind of scratches on a napkin. They were designed in a different world. As we rapidly shift to this cloud-native world, it's time we rethink this middle layer. And if you look at that middle layer, just clicking into the numbers there, it's a huge market. I mean, every analyst has different numbers here, but it's easily a $50, $60 billion market with 80%, a majority of the spend, still going into that classic, that monolithic relational database system bucket. Now we're starting to see the emergence of cloud-native databases grow and some adoption there, but there's still a huge opportunity to go. And IDC projects this market's just going to keep growing. Data is not slowing down. Apps are still getting written. We need to be able to store that data, and so databases is growing to a $100 billion market. So kind of what I want to leave you with in this section of kind of when is the right time, if you found a way to invest in cloud modernization, if you're on your journey in app modernization, those are key next steps. But to truly maximize, optimize this full end-to-end modern stack, make sure you're not forgetting that middle data layer. And we're starting to see the trends. Again, if you look again, going back to DB engines and the kind of the progression, the rankings of distributed SQL vendors, these are some of the fastest growing products out there in the data space. And we'll talk about in the rest of the session really kind of why that is. So if you've got cloud app modernization, at least in grasps, it's time to look at database modernization. Which brings up the next question of what? What do you modernize with? And this is where you start to dig into all these different terms that are out there. We've got NewSQL, you run into distributed SQL. Many people still use these interchangeably. And I'm not going to get into a semantics discussion. You can call it whatever you want. But I do want to peel back the fact that as a lot of us talk about these technologies, especially from Yugabyte, as we talk about distributed SQL, as we're here at DSS, we do think of certain characteristics that are very unique to distributed SQL that are fundamentally different than what's happened with some of the past things that we're doing. And to kind of peel back the differences, let's start by just recognizing what is the overall problem that they're addressing. Whether NewSQL or distributed SQL, this kind of recent emergence of new database technologies and looking to kind of bring that to the next level, why are they being created? And fundamentally, what the industry is trying to tackle is they're trying to combine all the goodness that NoSQL brought with scalability and resiliency. All these features are essential to a cloud-native application in our world today, but they want to still combine that with the consistency, the performance, the transactional support that comes from that classic relational data model. We still have systems of record. We still need to keep track of product catalogs, of gaming interests, of financial transactions. All of those require the strong system of record, but we need to do so in a highly available, distributed manner. And that's really what we're trying to do here, is bring together the best of these two worlds. And to kind of frame the difference then, to get into this next misconception, is NewSQL and distributed the same? I've got a great analogy I like to use, and so I'm going to walk you through that. I'm a little bit of an electric vehicle, EV car person. I enjoy cars. I've been tracking it since the beginning. And so I want to kind of use the progression of that industry, of how the automotive industry has changed, as a great example for what we're seeing with NewSQL and distributed SQL. If you think about the automotive industry, they've relied on combustion engines for 100 years. We've optimized it, we've focused on innovating around it, but fundamentally, that core architecture of how the car works, how that combustion engine works, hasn't changed that much. Up until 10, 15 years ago, when we started to finally see these investments in how do we find alternative ways to power our car, to drive more efficiencies out of our vehicles. And I want to use two examples. About kind of 15 years ago or so, we really saw, back in 1997, we saw Toyota release the hybrid Prius. So the Prius took the classic car, but combined it with an electric motor, an electric system, battery packs, to help give it an additional boost. So to drive up efficiencies of the combustion engine with this kind of supporting added-on electric motor to really drive up that efficiencies. And we saw it. It became a kind of most popular commuter car. We saw it over the place. You could get your HOV stickers if you're in areas with those. But I want to compare that to what we've seen a little bit more recently with Tesla. They launched the Model S car in 2012, and Elon Musk was really pushing to fundamentally change the vehicle and really thought about, okay, how do we rethink this from the ground up? So we'll use these as our two parallels to this NewSQL and distributed SQL discussion. Clicking into the first one then, this hybrid model of the Prius. Again, ultimate goal is to increase car efficiency, and they absolutely did that. They took that core combustion engine, combined that electric motor, and saw tremendous improvements by getting that assist. The batteries in the Prius would recharge using the motion of the combustion engine as it went, and again, it was able to maintain this high levels of efficiency. But if you peel back the architecture, you see, again, an electric motor bolted onto the combustion. You still had all the challenges, all the complexities, all the downfalls of a combustion engine. It still had the exhaust from a pollution standpoint. You still had to go get your oils changed. You still had all these moving parts of moving gasoline around, moving fluids and gases. You had to fill it up still. So again, legacy challenges were still there, but you did get some added benefits. So again, it moved us a step forward. If you look at NewSQL now, bringing it back to our topic at hand in databases, NewSQL took a very similar approach. We had things like Postgres and these core monolithic systems that worked really well. But as we got into this cloud world, they realized there was more and more of a need to scale that system. So NewSQL companies came on board and found a way to automate the sharding capabilities. So how do we provide some level of distributing this data automatically and relieving the developers, the teams, from having to do some of that scale? And it worked for those use cases. But still, under the covers, a lot of the fundamental architectures was still the same. It was still a monolithic single instance. So you still had all these different silos. You still had the kind of traditional async replication technologies for DR. You still had to do a lot of the manual processes. So it took a step forward, but you were still held back a little bit by a lot of those core legacy problems because the architecture didn't fundamentally change. So this is then where we shift and think about, again, what Elon Musk and the team at Tesla did with the Model S and the electric car. They really took the time and went from the ground up to really rethink what a car should be and how do we build it to embrace this idea of being an electric car. They rethought everything. They took, okay, how do we optimize the use of the batteries? They built it as a sled on the bottom of the car, so there was even weight distribution from front and back. It was a low center of gravity that could provide additional performance. They looked at all pieces. How does the console work? And they also had an opportunity to think about rethinking the design of the car and the steering wheels and the pedals. And Tesla could have gone a crazy route. They could have said, okay, we're gonna take and build a car that truly transform what we think about a car, and that's something that's brand new that people haven't seen before. They purposely did not do that. They chose this design, and if you look at the Model S, it looks like a normal sedan. Any car out there, if it's driving down the road, it resembles it. It has normal pedals that we as drivers are used to. It's got a steering wheel, all those features. So they embraced rethinking the architecture, but also making sure they still maintain some familiarity with what we think about as a consumer as cars. And that was critical. And it's a perfect parallel to what a lot of folks in the distributed SQL world, what we've done with Yugabyte DB is. One, we went from the ground up. We rethought that fundamental architecture, leveraging inspirations from things like Google Spanner, rethinking the storage layer, and the fact that the distribution of data is a native capability of that solution, building it from the ground up so that we can, again, optimize for replication, for availability, all those features that we need in a cloud native world. But similarly to what Tesla did, using a design of a car that they're familiar with, as you look at the API, the level on top of distributed SQL, we made sure there were familiar APIs. So as we're writing applications, if you're familiar with Postgres, you can just reuse all of that understanding, all of those tools, those processes you're used to, translates over. So the developer doesn't have to relearn a new language. Again, with Yugabyte DB, it's built on Postgres. You get that automatic familiarity and rapid adoption of it. So you get the best of both worlds of a modern architecture underneath this new storage layer, and then you get this approach of the familiarity on top of how you write applications and interact with it. And so we think about distributed SQL. What are those core characteristics? What are those qualities that are important in distributed SQL? It's that re-architected design that has automatic distribution of data. It has that SQL API for accessing and changing data. It's fully ACID compliant. So we have that true consistency that you need for systems of record for transactional databases. And then from a query standpoint, you have this distributed query. You can read, write from anywhere to those clusters and really maintain this distributed ability to do joins across this distributed database. So again, all those benefits. So we've had evolution. So if you kind of think about it as NewSQL as the 1.0 approach, the Prius, that first baby step into electric vehicle. And then we have the Tesla, which was really taking all those learnings and rethinking what does it mean to be EV. That's how I think about the NewSQL to distributed SQL progression. And to put this just in a table, so shifting away from our analogy here, what I've done here is you can just see kind of 4 big categories of databases, starting with SQL, we get to NoSQL, then NewSQL and distributed SQL, and then mapping these key features that we look for as you're evaluating databases, as you're looking for what's important to you in the database. How do these rank? And if you look at the SQL and NewSQL column, those are pretty much the same. Those capabilities are the same, except we get into that scalability column. This is where NewSQL provided that additional scalability on top of that. But then if you look at the right with distributed SQL, you can start to see definitely a drastic change here. So if I kind of do a loose highlighting of across each of those rows, what's kind of the best, what's the ideal setting for each of these rows. With schema and language, I recognize kind of dotted lines there because yes, there's benefits to being multi-model, but if you just need a relational database or if you just need SQL, then you don't care about those other features. So I'm not going to put too much weight in those. But then as we start to peel back these other qualities that are important to modern applications, scalability, consistency, replication, availability, the caching model for performance, and then of course this larger bucket of cloud infrastructure. What are those capabilities to be cloud native ready? You can start to see NoSQL provides some of those. NewSQL, SQL provide a little bit on consistency, but what distributed SQL has been designed to do is, again, take the best of all those worlds and bring them together. And that's really where the focus of innovation is. What we spent a lot of time today at DSS talking about is how are we delivering all these features and really bringing together all these things you need into a single database. So as you move forward, you have that database that can provide, again, the best of all these worlds. And good news is, you and your peers, we're seeing the adoption. Without a doubt, this is our largest DSS to date. And if you look at the market data out there from 451 Research, their Voice of the Enterprise, they're reporting that 58% of enterprises are using or planning to have globally distributed databases. So we see this number continue to rise. And again, going back to our DB Engines rankings, this number, we're seeing this trend move forward as we get more and more into the adoption phase, the mainstream of using distributed SQL. Which is a perfect segue to kind of the last topic here. So we talked about, again, when's the time? Hopefully that was a little bit of a good story on just helping you understand the architectural differences between NewSQL and distributed SQL. But now let's kind of get into, okay, why? Why are we seeing this growth in distributed SQL? What are those use cases? That as you're thinking about it, if you're new to this space, if you're just kind of starting to get your head around what this means to you and where it'll fit in your organization, what are those use cases to listen for and where you can start to make your life, your developers' lives, your operators' lives easier as you move forward. So this is based on our misconception that my database works fine. I don't need to invest in changing. And again, as I said in my opening summary slide, that's partially true. It's very much use case dependent, but let's look at 5 use cases that we hear repeatedly from customers that are driving the adoption of distributed SQL. And use case number 1 is absolutely the number 1 reason we're seeing this push, and this has to do with application growth. So as you have applications that are being built, a lot of times, especially in large enterprises, you're building tons of new applications, you're trying to solve a certain need, but you're never really sure if or when the growth of that application is really going to take off. When's it suddenly going to become viral? When's it suddenly going to see this mass adoption and require you to scale up? If we think about how that's scaling to work in legacy monolithic world, you basically were dependent on getting bigger and larger servers. So as your application took off, you suddenly had to procure larger servers, install them, kind of get them running, and then do that manual migration of the database from smaller to larger database. And that process just continued and continued. And it continued until you got to a point where you're buying massive servers that are no longer commodity hardware. These are powerful, almost custom-built servers to drive these large database demands. And again, as we talked about in our early phase about cloud infrastructure and that movement, a big shift of that movement was to commodity hardware. You just want to be able to use the standard simple servers that are out there and then cluster those together as you need to scale. And that's exactly, again, kind of the number 1 use case we see with distributed SQL. Its ability to scale horizontally, to scale out, cluster more and more servers together is just inherent in what it does. Just like as people, we breathe, we breathe, it's autonomous. It's just something that we just do. We don't think about it anymore. This notion of scale is just built into the DNA of distributed SQL. So as you bring in a new node to that cluster, the system has that intelligence. It recognizes that node, knows how to rebalance the data, and continue to grow out and expand out. And the benefit is that scalability, that linear scalability, allows you also to maintain that high performance. Again, being built with this notion of scale in mind, and this need, maintaining those low latencies and performance at scale is fundamentally to what it does. So app scale, number 1 reason we have customers come to distributed SQL is they're just tired of those challenges of scaling legacy systems, or they just can't anymore. They've hit their limits. Number 2, very much aligned to that first one, is the need that this always-on business, the fact that availability, resiliency is key. Data is essential to pretty much everything businesses are doing today. We're a data-centric world, so we need to make sure that data is always available. So as we think about those options there, again, going back to NewSQL, some of these monolithic systems, the challenge there is they still use asynchronous replication, some of the older replication technologies and kind of active standby systems kind of mean that you have manual cutovers. When you have failures go down, you have to get involved. You have to make sure you're reconciling all those final transactions. You have to make sure you're bringing up that passive, that kind of standby systems and up and running. So one of the big benefits as we think about distributed SQL is here we have a system that naturally pulls in again, those core capabilities where having the data automatically distributed, we have all these the ability to read write from any node. They're all active at all the same time. So if we lose a node, if we lose a region, a zone, an entire data center, the system again is built to be able to maintain and just keep running. It'll auto heal, it'll restore itself, and keep on going. So again, it's one of the kind of key benefits of distributed SQL is just being able to maintain that availability and handle those mission critical applications and keep running. Next up, app portability. This is one, again, coming up a little bit more and more, but as we talked about that shift to the cloud, all those investments you've done in cloud modernization and in cloud adoption, Gartner projects that 80% of you are using multiple clouds. So you're using multiple clouds. A lot of times that's a mix of kind of your existing private data centers, you're shifting into some public cloud. I was talking to a customer yesterday, it's basically saying they use all the different public clouds as well as having their own cloud in-house. And one of the ultimate benefits of this is you want to be able to move those applications into the environment that makes the most sense from performance, from cost reasons. And applications are relatively easy to move per se, but a lot of times it's the data that's holding it back, whether that data is tied to a specific cloud database or again tied to a legacy monolithic database system. Moving that data is the challenge. So as we think about distributed SQL, it acts as this unified single data store that could span across all different environments, whether that's public cloud, private cloud, hybrid cloud. We did a great example recently with some of our partners, AWS and Equinix, where again, we demonstrated that having this single unified database spanning both clouds, if we're writing data in AWS, we almost instantaneously see those reads in Equinix. So if you need to move data, if you need to make sure, move those applications and maintain data between the two, it makes life that much easier and creates this, again, single database that you're writing the code to, where that application runs, it doesn't need to know because it just sees this kind of single logical data store underneath it. Fourth use case, next-gen Edge. So 1.0 version of Edge was collecting a lot of information from those sources, phones, smart devices, factories, and bringing those back to a central database, a central data center, and processing it there. That worked fine. You don't need any magical database for that. But as we shift into 2.0 of Edge, where we see more and more data coming from not just the edge, but increasingly are writing applications to take advantage of that data at the edge, making real-time decisions, making instantaneous calculations at the edge. We need to be able to shift that database, shift those pieces out to the edge instead of just being local. And again, this is where the scale distribution of distributed SQL comes in, but then also the operational simplicity, being able to manage and operate this from one place without having the staff at all these locations. Being cloud and platform agnostic, having that freedom to run on any environment. If a certain hardware resource or certain cloud isn't available in a certain region, still being able to move that there and run it with that flexibility. And then of course supporting open standards. So as you're writing your application to this open standard, if for some reason one distributed SQL solution isn't available in one location, you have that easy flexibility to shift to something else because of those open standards and that shared language between different options. All right, we've gone through a lot. So fifth and final use case here is just tying it back to our original discussion of just microservices and Kubernetes. We talked about all that work you're doing on application modernization at the top. So now here we're focusing on how do we build a stateful database that can work in Kubernetes. And one of the key benefits of Kubernetes is that agility and the fact that Kubernetes comes and goes, pods come up and down all the time. So we need a database that offers self-service capabilities, has that self-healing, has that ability again to react to all of these changes that happen in a microservices environment. And again, all these features we talked about with distributed SQL do exactly that. So to wrap up here, we covered a bunch there. We talked about kind of when is the right time. Is digital transformation just tied to cloud and app? And the story is make sure you're thinking about that full stack. Application modernization, cloud modernization, database modernization. Treat that full stack end to end. Is distributed SQL and NewSQL are the same? We talked about our hybrid example. So just like the Tesla car compared to the Prius, distributed SQL fundamentally brings a new architecture from the ground up, and with it, all those benefits that align to what you need in a cloud-native world. And finally, can you address these use cases with an existing ICT stack? Maybe, but as you move more and more into these modern use cases, you're going to find that all of those capabilities that come with the distributed, always-on, high-performance, open-source, kind of cloud-agnostic platform are critical to your success moving forward across these use cases. So with that, thank you so much for listening. Hope you enjoy the rest of your time at DSS and reach out anytime with questions.